Ever wondered what could squish Mount Everest into a sugar cube? Meet neutron stars, nature's deadliest spheres. These cosmic monsters pack the mass of our sun into something smaller than Manhattan, and they're not playing nice with the universe. Let's rewind to the explosive moment when a neutron star is born. Imagine a massive star, way bigger than our sun, burning through its fuel like a cosmic bonfire. When it runs out of juice, things get wild. The star's core collapses faster than you can say supernova, crushing atoms so hard that electrons and protons smoosh together into neutrons. Boom! The outer layers blast off in a supernova so bright it can outshine entire galaxies. What's left? A superdense ball of neutrons, spinning hundreds of times per second. It's like nature's ultimate blender set to maximum speed. But instead of making smoothies, it's creating one of the most extreme objects in the universe. Here's something that'll blow your mind. If you somehow managed to scoop up just 1 teaspoon of neutron star material, and trust me, you really don't want to try this at home, it would weigh about 1 billion tons. That's heavier than all the buildings in New York City combined. The gravity is so intense that if you dropped a marshmallow on its surface, it would hit with the force of 1,000 nuclear bombs. This ridiculous density happens because the star's gravity crushes all the atoms together, squeezing out every bit of empty space until you're left with a ball of pure neutrons packed tighter than a subway car during rush hour. Let's talk about the most brutal blender in space. A neutron star's gravity is so fierce it literally shreds anything that gets too close. Stars, planets, even other neutron stars, they all get stretched and twisted like cosmic spaghetti. The technical term is spaghettification, and yes, that's a real scientific word. When a neutron star catches a regular star in its gravitational web, it starts stealing its material, pulling it into a swirling disk of doom. This cosmic theft creates awesome light shows and X-ray bursts that we can spot from Earth. It's like watching a celestial vampire feeding on its stellar victim, but with more explosions and less sparkly skin. Ready for some mind-bending space facts? These cosmic tops spin so fast they make your kitchen blender look like it's moving in slow motion. When a neutron star forms, it inherits all the rotational energy from its much bigger parent star. But here's the kicker. As it shrinks down to the size of a city, it spins faster and faster, just like an ice skater pulling in their arms. The fastest one we've found spins 716 times every second. That means its surface is moving at about 1/4 the speed of light. If Earth spun that fast, your day would be over before you could finish saying supermassive black hole. Pretty wild, right? Let's talk about the most powerful magnets in the universe. And trust me, these aren't your average fridge decorations. Neutron stars pack magnetic fields so strong they'd rip the iron right out of your blood from halfway across the planet. These fields are 1 trillion times stronger than Earth's magnetic field. Want to know what happens if you get too close? First, all your atoms would line up like tiny compass needles. Then, as you get closer, the magnetic force would stretch you like silly putty atom by atom until you're literally a string of molecules. It's like the world's most extreme taffy pull, except instead of candy, it's, well, you. All right, let's talk about the universe's most epic crash test, when 2 neutron stars slam into each other. These cosmic dance partners spiral closer and closer, moving at almost the speed of light. Each star weighs more than our sun, but they're spinning around each other faster than your favorite EDM beat. When they finally collide, wham! They release more energy in a second than our sun will in its entire lifetime. The explosion creates a light show that astronomers call a kilonova, which sounds like a fancy space dessert, but is actually where most of the gold and platinum in the universe comes from. That's right. The bling on your finger was probably forged in one of these cosmic mosh pits. Let's watch a neutron star's dinner time. It's messier than a toddler with spaghetti. When these cosmic vacuum cleaners find a nearby star, they start pulling off its outer layers, like someone unraveling a ball of yarn. The stolen gas spirals down in a massive disk, heating up to millions of degrees. It glows so bright we can spot these stellar buffets from Earth. The neutron star basically turns into a cosmic garbage disposal, pulling in material at speeds up to 100 million miles per hour. And here's the weird part. This stellar feast makes the neutron star spin even faster, like a figure skater pulling in their arms during a spin. Ever seen a lighthouse in space? Well, that's basically what a pulsar is, except instead of warning ships, it's blasting beams of radiation across the cosmos. These spinning neutron stars shoot out jets of energy from their magnetic poles like cosmic spotlights. As they spin, these beams sweep across space like a galactic lighthouse. When the beam points at Earth, flash, we detect a pulse of radiation. That's why astronomers in 1967 first thought these regular signals might be alien messages. But nope, just nature showing off its most reliable timekeepers. These stellar lighthouses are so precise, you could set your watch by them, if your watch could handle radiation that would fry every electronic device within a million miles. Let's get real about space threats for a second. A neutron star wandering too close to Earth would be game over, and I mean that literally. Even from a distance of a light year, its magnetic field would mess with Earth's electronics like a cosmic EMP bomb. Get closer? The gravitational pull would rip our planet apart like wet paper. The oceans would lift off the surface, the crust would crack, and Earth would stretch into a long noodle before being completely shredded. But here's the good news. Space is ridiculously huge. The chances of a neutron star getting anywhere near us are about the same as you winning the lottery while being struck by lightning. Twice. So yeah, technically terrifying, but practically, we're safe. Here's a wild thought. Our Milky Way has about 1 billion neutron stars lurking in the dark. But don't panic just yet. These cosmic wrecking balls are incredibly far away, and space is mind-bogglingly huge. The closest known neutron star? It's chilling about 400 light-years from Earth. That's like 4 quadrillion kilometers away. Over millions of years, some will drift closer to our solar system. The good news? We've got astronomers tracking these stellar beasts like cosmic wildlife rangers. They can spot them way before they'd ever become a threat. And even better, our sun's gravity acts like a protective force field, keeping most wandering stars at a safe distance. That's all about these incredible cosmic crushers. If you enjoyed this wild ride through the universe's densest objects, smash that like button and subscribe for more mind-bending space facts. Share with your friends. Their minds need blowing too.